Hello everyone, welcome back to Let's Unbound. We are kicking off an exciting new series for AP Precalculus students where we will break down every concept one topic at a time. In each episode, you can expect a clear, quick overview of the concept and then we will dive into problem solving. Basically, there will be three problems from basic to advanced level. So the difficulty will be from low to high. So we believe that this will help you to build the problem solving skill and make your conceptual understanding much better. So whether you're reviewing or you're learning this for the first time, you're in the right place. So be ready with a pen and paper and also with your calculator and solve along with me. Let's start with 1.1, change in tandem. So what is change in tandem basically? It means one quantity changes, the another will change along with that. Either it can be in an increasing way or in a decreasing, like in a related manner. So this change in tandem concept in math, we will apply in functions. So a function, we know a relation in which each input corresponds to exactly one output, right? Many relations we can form, but all of them are not functions. Only if they satisfy this, every input exactly one output. And when we talk about input and output, set of all input values, that is basically x values is your domain. Set of all output values, we call it as range, right? Now, if you see something like this, if a quantity y changes in tandem with another quantity x, then we express this as y equal to f of x. So here we know input output. When you say a variable, you should be able to classify these two variables, which is independent and which is dependent variable. So independent is your input basically, and output, whichever comes for output, that is dependent variable. So here one example scenario, height of a ball over a time is modeled by h of t, 54t minus 16t square. So here independent variable is t. So basic question is, h of t is modeled, it's based on, it's made up of t, right? So independent is t and dependent is h. If you say time t, I can tell you the height. That's the basic way of asking a question and answering, right? So if I say the height, you say the time, that is possible from graph, but that is not the first approach you will do, right? So independent, time will decide the height of the ball, basically. So time will decide. Based on the time, the height answer will be dependent on that. So this is how we need to classify independent and dependent. Now, a function can be represented like this, also in some other different forms, mapping, table, graph, and ordered pairs. Mapping, they say when 0 is your input, you got 2. When you give 2, it's 4. Same thing, we are making in tabulation form, xy or t, h of t, whatever. And ordered pairs, so this tabular form in XY format we are writing so that it will be easy to plot it in the graphical way. So ordered pairs, then you can plot that and you can get the graphical form. Now, a quick review on which is function, which is not a function. First mapping diagram is a function. It follows every input exactly one. A is going somewhere and only one place. Similarly, B and C. Here, B is a problem. It's not a function because every input have some destination to go. But B is going to two places. So imagine you are in two different countries at the same moment. It's not possible, right? So it's not a function. So that is a scatter plot diagram. This graph is given. So this is a function. This is not a function, right? So this is the problem. When x is equal to 1, there is two answers, like two results, which is not a function quality. Now, very important thing. So far, all the basics that you already know, it's just a review of it, a quick review on that. Now, increasing and decreasing function. A function will be increasing maybe throughout its domain or at some places, like some intervals of time. So when I can say function is increasing, if your input increase, the output also will increase. In that case, it is an increasing function. So one example in analytical form is given, and formal definition is this. So a less than b, this is your inputs. You take two numbers like 1 less than 2. The outputs also should follow the less than inequality. So it is a increasing function. So basically in a graph, okay, let's see. So 0, 1, 2, your function result is also increasing. X increase, Y also increase. So formal definition, if you apply, 1 is less than 2, Output you compare, what is the output of 1, 5, output of 2, 7, that also satisfies the same inequality. So this is the way we can check with tables and the formal way of checking. Decreasing means if your input increase, but the output decrease. This is one such function example. Formal definition, if A less than B, f of A will be greater than, okay? F of A greater than f of B. So you increase the x values. Sorry. So you increase the x values, but your results, output, f of x is going down. This is decreasing function. So A less than B, 0 is less than 1. What happens to f of A? F of 0 is 4. And f of 1 is 1. You got a graded. So A less than B, but f of A greater. Like if they behave opposite, they are decreasing function. Right? Now, graphical way. Increasing and decreasing in a graphical manner. So two lines are given. Right? So place your finger on the graph and you need to move on the right side of the coordinate plane. If your finger goes down, it's decreasing. So this is my finger, if you imagine. I go right side, okay? So I'm not going like this. I'm moving left. So right side, if you move, it goes down. So this is decreasing. The green one is decreasing function. So left to right, if it goes down, it's decrease. You place the finger on the blue and move right, you will be going up. So this is increasing function. This is throughout increasing, but something like this. This function is increasing from here to here, right? Then from here to here, your finger will go up. So till this is increasing. From here to here, it's raising up. This is increasing. So this kind of partial increase, partial decrease also we will face. Right, next one, concavity and some other important graphical features. So whenever we draw the graph, there is one important thing where the graph crosses x-axis. We call it as zeros or sometimes x-intercept. And also where it crosses y-axis. That is also an important essential feature of a graph. While graphing a function, we will use that. Then increasing, decreasing behavior. Apart from that, the shape of the graph, which is concave up and concave down. Okay. So concave up means it's a cup shape. In short, concave down means it's down. It's a cap shape, something like this. So it's decrease. After a point of time, it's increase. So the function goes from decrease to increase or increase to decrease. You will get a shape like this. So that is concave up or concave down. Now, one more thing is point of inflection. Where your concavity changes, that is there will be a point of inflection. For example, I make a cup shape, then I make a cup and cap shape. So where it changes concave up to concave down here. So this is the point of inflection. Where the shape of the graph changes, that is the point of inflection in general, right? And here we are moving. So you can just also do this by drawing tangent line. So pick any point, like they draw two tangents. Here one tangent, and right side they pick another point tangent. So tangent is keep on increasing, right? So if tangent is increasing, it's concave up, and when tangents are getting decreasing, it's concave down. That way also we can check the shape of the graph. But the very easiest way is this cup cap way. And let's go into get into the problem solving. A bicycle rental shop charges a fixed fee of $10 to rent a bike plus $5 per hour. The bike is rented. Customers can rent bikes for anywhere from 1 to 8 hours in whole hour increments only. So identify the independent and dependent variables. So the cost will be calculated based on your hours. So the hour is playing an important role. Based on hours, you can tell the cost. So independent is hours. You can take 1, 2, 3, 4, 5, 6, 7, 8, right? So the number of hours bike is rented. This is independent. And dependent variable, based on that, cost will be dependent on that, or a charge you can say. So the cost is dependent. So write a function. Let's give a perfect naming. Cost, so I'm starting with C. It depends on hours. So H. C depends on H. Okay, what is the rule? 10 fixed fee. So 10 plus for every hour, you have to pay 5 for every hour. So if you take 1 hour, pay 5. 2 hour, 5 times 2. 3 hour, 5 times 3. So that is the variable h, number of hours unit. So C of h is 10 plus 5h. This is your B. Now, determine domain and range. Okay, I have a function now. C of h is 10 plus 5h. Domain is all the possible input values. They said clearly you can rent it from 1 to 8 hours, only whole number increments. So 1, 2, 3, 4, 5, 6, 7, 8. No decimal, no fraction, no other numbers, just whole numbers. Now coming to range. Range, you need to find every possible input. Actually, it's a quite easy process here. So 1 hour, it's $15. 2 hours, you just plug in 2, you will get 20. Then 3, you plug in H. 15 plus 10 is 25. You see, it's constant 5 increment. Of course, it's a constant thing, right? So 25, then 30, 35, 40, 45, 50, 55. No, not like that. Only 8 hours. So we have to do till the 8 only. So 3, 6, 7, 8. So maximum is $50. That's it. Very simple question on change in tandem, basic domain and range, and modeling a simple function. Now, question 2. A small business tracks its weekly profit in hundreds of dollars based on the number of weeks since it's launched its marketing campaign. So week W and profit is given. Identify the independent and dependent variables. I can hear your answers. Independent is what? Week is independent. You take 2 weeks, 4 weeks, it's independent. It's free. And profit depends on your week. I can say the answer only if you say how many weeks or which week, something like that. So, right? So, week is independent and profit is dependent. Use the table to describe when the profit is increasing and when it is decreasing. So, from, let's see, week is increasing in number, profit 2 to 4 is increase, 7 to 10 increase, 12 increase, 12 to 13 increase, 13 to 13, it's stagnant. It's levels of here. So from week 2 to week 0, like within a week of completion is week 0. Week 0 to week 5, it's increasing. And also we can see 6 to 7, decreasing, right? So sorry. So week 0 to 5, there's an increase. When it is decreasing, you can't say 5 to 7 because 5 to 6, there was some level of like no change, neither increase nor decrease. So 6 to 7, it's decreasing. Week 6 to week 7, it's decreasing. Right, now question number 3, estimate the domain and range of the function P of W. Domain and range is very simple here. Table of values is given. Let's go. Domain is number of weeks, 0 week, within a week, 1 week, 2 week completion, 3, 4, 5, 6, 7. And range is 2 to maximum 13. So 2, 4, 7, 10. The only one thing here is it's easy listing, but you might make an error repeating 12. So 12 comes, whatever number of times let 12 comes up, you are going to use only once, and 13 also. Okay, it's not necessary domain is having 8 elements, then range also should have 8 elements. No, not like that in this set notation. Okay, if something repeats, just enough to represent in one at a time. Okay, domain and range is over. Based on the table, describe the general shape of the graph. Example, linear, like increasing or decreasing, or how it is based on your understanding. Okay, so is it linear first of all? Let's see. Linear means constant change. So profit, this is actually well spaced, right? So 0 to 1 week, 1 to 2, like gap is 1 week. Here, 2 is the increase. Here, 3 profit increase. Here, 3. Here, 2. It's not a constant. 2, 3, 3, 2. Either it should be all 2 or all 3 or all something all equal. So here we got 1, here we got 0, here we got -1. So this is not a linear. So you can just mention non-linear as of now. We just step into the first, right? So non-linear is enough. And then we know from 0 to 6th week, 5th week, 6 here is what we can change. So 0 to 5, it's increasing. Okay, let me put 0 here. 0 to 5, it's increasing. 5 to 6, it's level off. 6 to 7, it starts dropping down, something like this. So something concave down, I can say about the shape, right? So cap shape is concave down. So non-linear and concave down, increasing, decreasing also we have discussed. So increasing, levels of decreasing. So this is the general description of the shape of the graph, what we observe from the table of values, right? So this completes question 2. I hope you might get some better idea here. Now we are moving into Q3, analyzing graph, a very important for your exam point of view. A graph is given to us. On what intervals is the graph concave up? On what intervals is the graph concave down? On what intervals it's increasing, decreasing, find zeros, y-intercept, identify any points of inflection. Almost we are going to analyze every key features of the graph. Let's do this graph. Let's go with concave up and down. It's here an important thing. The common mistake that we will do is concave up means cup shape. So this is a cup shape? No. Also, that is for reference, of course. So decreasing to increasing manner. So it's decreasing, decreasing. Here they will have a turning point, then increase. Okay. So should I take till this it's increasing? No. So actually, this is wrong. So you can't say it's from A to D. This is not how it will work. Let me tell you why. The randoms will keep on increasing, right? So it should face down. When you observe this, here, this face down. So this is what facing upwards. Okay. So if you go here, you are mentioning concave down also. So it's kind of concave downwards, right? So the concave up is from here to C only. From here, you can notice it's looking downwards. So that's carefully you should look up here. Okay, so how to write the intervals? So from negative side, we don't know where it is, like is it A or something. So let's make it's going on and on both ends. So from minus infinity to C, it's concave up. Then from C to positive infinity. Okay, the intervals I'm working on is X values. Okay, so from C means, so from minus infinity to C, it will be concave up. C to plus infinity, it will be concave down. Now, where is graph increasing, decreasing? Maybe you can do that here. Increasing, decreasing. So you start from your left side and come, it's coming down, down. Your finger is coming down, down, down here. So decreasing. Then it's increasing here. Your finger will start going up. Okay. You're moving up and up, up. Okay, here we are stagnant. Then we will keep on coming down. So when you go for interval of decreasing, right? So two intervals from minus infinity to till this B point. And then there is a break. You want to say another decreasing part, that is D to plus infinity. And if you want to join them, yeah, you need to join them using the union. Okay. Or the other way is for x less than b, this is can be written as x less than b or x greater than b. This way also we can say. Okay, interval notation in equal. So basically we can go with the interval notation as they are asking on what intervals. And yeah, increasing part now. Increasing is from b to d. Okay, so b to d, it's increasing. So no need to worry, should I use close bracket or a round bracket here? At B and D, we don't know. Actually, it's neither increasing nor decreasing. So just move it on bracket here. So increasing, decreasing is over. Zeros, y-intercept point of inflection. Zeros means where it crosses x-axis. Graph crossing here, here, and here. So zeros at x is equal to, your answer should be x is equal to A, x is equal to origin, their name. So let's say origin and then E. Then coming to y-intercept, where it crosses y-axis, don't write no y-intercept, it's a wrong answer. Origin is also a valid y-axis, right? So you can say 0, y-intercept at 0. Y-intercept is 0, right? Then what is next? Point of inflection. Point of inflection, I hope you remember, concave up to concave down, that particular point. So we already analyzed what is concave up and down. So concave up to concave down. So here the shift happens. That is your point of inflection at x is equal to c. Yes. So this completes the question number 3. So yeah, now I have a bonus question to you. So this is a modeling question. Analytical form is given and 3 sub questions are given to you. So do solve this, and you can post the answers in the comment box, right? If you got decimal answer, you can round it up to 3 decimal places. Like if it's a cost, you can just make it in cents, right? Dollars and cents form. Right. So I hope this video might be helpful to you. If it helped you, you can just like, and you can save this playlist for your future reference. And also you can subscribe and hit the bell icon so that you will get notified whenever we upload a new video to you. Right. So yeah, and also this is a QR code to join our Let's Unbound Student Community WhatsApp group. So you can get the exam updates if you have joined the group. Also, a link is given in the description. Right. Thank you so much for joining today. We will be meeting in next video, that is 1.2 rate of change very soon. Until then, keep learning and keep practicing.